A girl jumps off a high dive board in a pool in such a way that she passes the board 3 meters above the water with a downward velocity of 4 meters per second. How much time passes before she hits the water? So let's kind of complete the picture that's up here. At this point, she's going to fall an additional 3 meters down to the water. All right, so let's look at what we know by listing our givens. So this is what I know, or my knowns, whichever you want to say. So the initial velocity is equal to negative 4 meters per second. Now I'm going to say negative because it's going downwards. The acceleration due to gravity, so it's in free fall, so I know what the acceleration is going to be. It's going to be negative 9.8 meters per second squared going down. And that's true for all objects that are in free fall. In other words, they're moving due to gravity with no control over their motion. And the distance I'm going to travel is going to be 3 meters down, so it's also going to be negative 3 meters down to the ground. And my initial velocity, my initial position, we're always going to make 0. So wherever we start, we'll call that 0. So let me start with this. And when I look at this and I look at my equations, I think, well, really the way to go about this is going to be using x equals x naught plus v naught t plus 1/2 at squared. So let's start with that. X equals x naught plus v naught t plus 1/2 at squared. All right, and when I do this, I know that x naught is going to be equal to 0. So really this is x is equal to v naught t plus 1/2 the acceleration times the time squared. All right, so let's put some numbers and units in. Negative 3 meters is equal to the initial velocity, which is negative 4 meters per second times the time, that's my unknown, so I'm trying to find, plus 1/2 times, let's see, at, so it's going to be negative 9.80 meters per second squared times the time squared. Okay, I can rearrange this a little bit. I'll move the 3 to the other side. So that becomes 0 is equal to 3 minus 4t minus 1/2 of 9.8 is 4.9, so minus 4.9 times t squared. Oh, wait a minute, I got t and t squared. I can't just divide everything by t because I'll lose one of the answers. So to solve this, I've got to use the quadratic formula or some way of looking at quadratics, like completing the square or something else to do that. So maybe I don't feel like doing this. There's got to be another way to solve this that might be a little bit easier. And there is. So let me go ahead and get rid of this real briefly. Let's try another method. So if I had one more given over here, I could probably use a different equation, like v equals v naught plus at, because I'm looking for the time. But I don't have the velocity over here. If I just had some way of finding the velocity, then I'd be able to find the time in the second step. Oh, wait a minute, I could do that. I could use my variables up here to find the velocity, and then use those, the answer for the final velocity, to find the time. So I'm going to do that instead. It's 2 steps, but it's still easy to do. All right, so here we go. I'm looking at my numbers up here, looking for velocity without time. That means that I'm going to use v squared equals v naught squared plus 2ax. So, whoa. All right. So let's see. V squared equals v naught squared, so that's negative 4 meters per second squared plus 2 times acceleration, negative 9.80 meters per second squared, times the distance, which is negative 3 meters. Great. So when I do this, I get a value for v squared of, let's see, 74.8. But that's not the answer. I got to find the velocity. So the velocity is the square root of that number. So that's going to be plus or minus 8.648. 8.648, and I'll put another number on there, 8.648, 699 meters per second. So plus or minus, whenever you take the square root, you get 2 answers. One's positive, one's negative. Well, I know that this diver, she is going down when she hits the water, so that's going to have to be velocity is going to be a negative 8.648699 meters per second because she's going down. So that's the final velocity. That's what I'm going to use right there. Negative 8.648699 meters per second. All right, now I've got to find the time. So now can I use my givens up here to find time? So I've got this new one for a reason, this new variable. So in finding time, I can use v equals v naught plus at. So my final velocity is going to be negative 8.6486. I'm running out of room, equals my initial velocity, which is negative 4 meters per second, plus, let's see, plus negative 9.80 meters per second squared times my unknown, time. All right, so negative 8.6486 meters per second minus, or equals, negative 4 meters per second plus 9.80 meters per second squared times time. So I can move the 4 to the other side by adding it. So when I do that, I'll get 4.8, oops, that's not right. I'll get 4.6486 equals negative 9.8 times time. Then to isolate t, I've got 9.8 times time, so now I've got to divide both sides by 9.8. And when I divide both sides by 9.8, I get a time of 0.47, let's see, 4 seconds. So that's the answer. That's how much time it'll take for her when she passes the board and hits the water. The key thing to solving this problem is to remember that because she's going down, the acceleration is going, the final velocity is going to be negative. So as a recap, we started solving this and we got ourselves boxed in the corner, having t and t squared. We didn't have a way to quickly solve it available to us, or maybe we just uncomfortable with the quadratic formula, whatever reason, and we just needed to find one more variable so we could use a different equation, like v equals v naught plus at. So that's what we did. We used v squared equals v naught squared plus 2ax in order to find the final velocity when she's going down the water, made it negative, and then used the VOAD equation in order to find the time.